Hi class, we need to talk about the next topic, and in this topic we're gonna actually go back and review outliers, and in this case, or in this actual section, we're basically gonna call them unusual scores. So here's the idea. So the first scenario that we're actually going to encounter is a data set that happens to be technically bell-shaped. And then the portion that we're looking at is basically this section that happens to be within a total of 2 standard deviations away from the mean. And the main idea is that if the data is bell-shaped, so you're only looking at, well, the interval that's within 2 standard deviations away from the mean for any value that happens to be okay within the distribution, and extreme values are actually outside of that. So the first topic that we talked about was outliers, possible outliers, and those were values that were technically here. So they were technically on the extremes, and remember that your distribution goes on to infinity. So when we talked about possible outliers, we basically were just looking at the extremes, in this case, the actual edges of the distribution. Now, if we're looking at data that it's bell-shaped, and they're asking us to find, or in this case, to determine if we have unusual scores, your unusual scores will be your outliers. But since we are not given information if all the data has been collected for a population or sample, we're just going to call them unusual scores. So any unusual score is any score that's outside of this interval of 2 standard deviations away from the mean. Or if you were to calculate its C-score, well, whichever case happens to be, if it's a sample or a population, that happens to be outside of 2 standard deviations away from the mean. So any value that we expect to have, it's going to be within 2 standard deviations. So we're looking at technically this spread of data. Any value that's outside, we're going to call it unusual, but we're actually referring to, in this case, outliers. Except, like as I mentioned, we don't know if we have collected all the data, so we're just going to basically refer them as unusual scores. So let's take a look at the first example. Actually, wait, I forgot this portion. So the second scenario is, what if the data is not bell-shaped? And the problem is, if the data is not bell-shaped, we may not know what it looks like. So in that case, any unusual score, it's actually going to be calculated by finding the lower and upper fence. And the lower and upper fence gets evaluated by finding the fences. By finding, I mean the actual value of Q1 minus 1.5 the IQR, and Q3 plus 1.5 the IQR. And that's going to give us an idea of basically where most of the data should be, given that we don't know if it's bell-shaped, and then any value outside of that interval, it's going to be considered unusual. But let's take a look at an example. So this is the most likely scenario that we could encounter. We're looking at a data set, and the first question, and actually this is considered to be a population. The first question that they ask us is, do you see any possible outliers? Now, remember that outliers, and here we're told that the data is bell-shaped. So this is huge because we know that if it's bell-shaped, we're looking at this scenario. So we're looking at 2 standard deviations away from the mean, and we're basically looking for possible outliers on the edges. So for this one, since it just mentions possible outliers, the data set appears to be in order. So the only possible outliers may be the 10 and the 90. So only possible outliers are 10 and 90 because they are far from the rest of the scores. And the portion that we were talking about far actually refers to, it's likely that it happens to be within a total of exceeding the 2 standard deviations away from the mean. So if they're just asking about possible outliers, we're technically just looking at the extremes. So that's actually it for question number 1, any possible outliers. Now, the next question, we're actually gathering evidence for the possible outliers. and they're asking us, do we see any unusual scores? And they want us to find the proper interval. So in this case, the actual interval is going to be calculated as follows. So the interval, it's actually going to be, and we're treating this as a population. So it's going to be mu plus or minus the values of 2 sigma. And let me actually run the data set. So please take a second and enter the data set. And let me just double check that I don't have any typos. 10, 12, 15, 25. Okay, so I think we're good. And let me run the one variable stats. And for this particular problem, we just need two calculations, which is the mean. And in this case, well, mu is approximately 35.67. So let me write it as the actual sum of the x's divided by n. And this is going to be approximately, so 35.67 based on the output. And the standard deviation, actually, it's actually, let me write it as sigma is equal to the square root of the sum of x minus mu squared divided by the values of n. That happens to be approximately 24 point, I'm just going to keep 2 decimal places, 24.12. So approximately 24.12. Now, for the actual interval, we're just going to be plugging in those values. So it'll be the 35.67 plus or minus 2 times the 24.12, which is actually going to give us the following interval. So please evaluate, and I'm just going to write it as mu minus 2 sigma and mu plus 2 sigma. So take a second and punch it in. Okay, so let me tell you what I'm getting, and then we'll round it in a minute. So I'm getting for this one, lower limit. Okay, so the actual lower limit, I'm getting negative 12.57 to 83.91. Now, we do have to do a rounding. And in this case, the data actually represents minutes. So for this particular one, you can't have negative minutes. You're gonna have 0 to 83.91, and we typically round to what the data set happens to be, in this case integers. So technically 0 to 84 minutes. Now what this means is that most of the data, it's actually going to be within 2 standard deviations away from the mean, and that's all the scores that happen to be 0 to 84 minutes. Now, from our possible outliers, that actually includes 10, but it does not include 90. So here what we would say is that the only unusual score is 90, since 90 is outside of the usual interval. And our usual interval happened to be 0 to the values of 84 and technically minutes. So you have to make sure that you write it in a format that it's clear that technically you're looking at an interval, and that's what where we should have 95% of the data. So in this case, going back to this first portion, we're basically looking at that portion of the data set that's within 2 standard deviations. 90 happens to be in this extreme value. So it's very likely that it's an outlier. In this case, we're just going to basically call it unusual, but it is referring to outliers. Okay, let me go to 10. And it's asking if 10 is an unusual score. They want us to use the C-score for this question. Now, this is what it's referring. If you're looking at C-scores, then you're looking at C-score values that happen to be within -2 to 2. So that means we have to evaluate the C-score. And the data happens to be a actual population. So let me just copy the original values. In this case, it was 35 and 24. So we're going to have that x is equal to, so x is equal to 10, and its C-score is going to be x minus mu divided by sigma. The values of mu we had as 35.67, and then sigma was 24.12. So I'm just referring to those two outputs. And then the proper calculation for the C-score, and C is equal to the values of 10 minus 35.67 divided by 24.12. It's going to give us that C. It's approximately, and let me evaluate this. Okay, so please check it, and I'm getting -1.06. C-scores, we're rounding to 2 decimal places. Now, our proper answer here, it's going to be that no, 10 is not an unusual score. Because the C-score for x is equal to 10 is technically z approximately, I'm just going to put equals to -1.06. Wait, it's supposed to be 0.06, and -1.06 is within, well, the C-scores of -2 to 2. And this represents usual C-scores. Okay. In this case, this happens to be our main answer. If this particular value of a C-score happened to be greater than -2, then in that case, yes, we would have said it's an unusual score. We could have actually seen that 10, it's actually within the usual interval from 0 to 84. So if we already did the actual calculation of the interval, we would have been perfectly fine. Now, let me stop here for a moment because I'm running out of time on the actual recording. I'll do D on the next video.